I'm going to go ahead and walk through the process of completing the square to solve a quadratic equation. Now, over here to the left, these are basically your step-by-step directions for how you actually complete the square. And then this is just a random example problem that I'm going to follow these steps to show you how to solve using this method. So as you can see, the first step is if there is an a value that is not 1, we need to divide that out of the equation. Well, if you look at our problem, our a value is 1. Therefore, I don't need to worry about this specific step. So this is nice in this example. Our next step is to move our c value to the other side of the equation. And what we are going to do here is take x squared plus 6x. We're going to leave that. I'm going to leave a little bit of space here. I'll explain why in a minute. And then I'm going to move that negative 8 over. It's now a positive 8. So I'm starting to get my setup ready for completing the square. Step 3 is the biggie. This is where you're actually going through the completing the square process. What we want to do is create a new c value, and we want this new c value to make this left-hand side of our equation factor into the same two quantities. That would make it a perfect square trinomial. In order to do this, in order to figure out what this new c value is going to be, we're going to use this little trick right here. We take half of this b value. So I'm thinking to myself, half of b is 6 over 2, which we all know is 3. And then I'm going to square that number. And when I square 3, I get 9. Now, you should also remember the rule from algebra that whatever you do to one side of an equation, you must do to the other. So not only am I adding 9 here, but I'm also adding it to the right-hand side of my equation as well. I do just want to take a second to stress the fact that the sign in front of b does not matter. The reason for that is you are going to square this quantity anyways, so even if this would have been a minus, we would have had a negative 3, but we would have squared that negative, in which case we would have had a positive 9 regardless. So please don't worry about this sign when you're figuring out this new c value. All right, with that said, I'm going to give myself a little more space here. What I mentioned earlier is that we did this so that we could factor this left-hand side into the same two sets of factors. I'm going to go ahead and add that 8 and 9 right now. When I factor this, x, add to give me 6, multiply to give me 9, that's a pretty easy answer of 3 each, and they're both plus. So the left-hand side now factors, because it's the same two quantities, I'm really only going to write them one time. It's x plus 3, quantity squared. And that's going to equal 17. A couple of shortcuts here. I would say most of you can skip this step. There's no need for you to have to write this out twice. You should realize you can write it as 1 quantity squared. Another shortcut is realizing that the number that's going to go here in the factor is always whatever your b over 2 was. So my 6 over 2 was 3. That's how I knew this was going to go here. How do I know if this is plus or minus? That's usually dependent on the sign in front of your b value. So that's what this sign is really going to be important for and useful for when you're completing the square. All right, so we are all the way down to step 5. Now we're ready to solve, folks. We can just square root both sides, and then we're going to be able to get x by itself. So we have an x plus 3 on the left. Don't forget, when you're solving and square rooting, you need a plus or minus in front of that radical. Square root of 17 does not simplify any, so folks, we are left with a final answer of negative 3 plus or minus radical 17. All right, what I would like to do next is do another example with you. This one has an a value in front, so I kind of want to show you how that looks when we actually have to go through and do that very first step. So the very first thing I do is I divide both sides by 2. That gives my a squared a value of 1, which is what I need to do the rest of this process. So now I'm ready to move my c to the other side. You may already be kind of moaning and groaning. I understand that. Just realize that when you do have to divide that value, many times, yes, that does mean you're going to have fractions to deal with. Fractions really are not that bad. All right. Another moaning and groaning issue might happen right here when you look at this b value and realize it's odd, and you're supposed to take half of it, which, folks, yes, that means it's another fraction. Again, really not that bad. B over 2 is 3 over 2. I'm ignoring the negative because I'm going to square it in the long run. Don't change this to a decimal. Don't be weak. Leave it as a fraction, and then you need to square it. Squaring a fraction is very easy, folks. Square the numerator, square the denominator. So what I would like to add to both sides of my equation this time is a 9/4. And then if you remember the little trick that this side should now factor into the same two quantities, x, whatever your b over 2 was, is the number you're looking for, 3/2, and whatever the sign in front of the b value was is the sign we're going to use here. So real easy, not too bad. The fractions really haven't given me a hard time yet. Right here might be your only trickiness, and that you need a common denominator. From getting a 4 here, I need to multiply by 2. So it's really a -2/4 I have. -2 plus 9 is a 7/4. And now I'm ready to finish solving this. I'm going to square root both sides. So I have x minus 3/2 equals plus or minus, don't forget that. I'm going to go ahead and look at this as the square root of the numerator over the square root of the denominator. The reason I like this is because my denominator is a perfect square, so it comes out that I don't have a radical down there, and that's good because I didn't want a radical in the denominator anyways. And just to finish this off here, I'm going to add my 3/2 over. So I have 3/2 plus or minus radical 7/2 as a final answer for this quadratic. So this is completing the square when your a value is not 1, and also a good look at some of the fractions you see happen when your b value is odd as well. I hope this helps.